And there we go. So Frank Gill is with us, and he's going to be speaking about configuring availability groups in the Azure Portal. Frank is works for Fortified Data. He was a one-time leader of this group back when we were called Chicago SQL Server User Group. And he's a speaker of user groups, SQL Saturdays, and he's also presented at the past summit. So, Frank, take it away.
All right. So as Ross said, I'm going to talk about configuring an availability group in the Azure Portal. It's a preview feature, so I'm going to go through the portal and actually run through building this out. Because it's a preview feature, the things that you see tonight may change. I will go through the portal, but I've got the slide deck, and the slide deck has got screenshots, and the slides are currently hidden. But I will send the slide deck to Ross, and if you want to run through this process, you can do it using screenshots. So just a little bit about me. Been in IT for 24 years now, which is hard to believe. The last 16 of it, I worked with SQL Server, and for the last 7 years, I've been a consultant, as Ross said. Currently work with Fortified Data. My focus is on high availability in Azure. Cut my teeth as a kind of traditional DBA, so I was in charge of maintaining the SQL Server environment. And now with Azure, I help people build things out, troubleshoot things, you name it. I'm a voracious reader. I love museums, and then my contact information is there. My blog is fairly dormant. I'm trying to change that. Twitter, which may or may not go away anytime soon, and email. So if you have questions about anything I talk about here, and feel free to ask them while I'm presenting, but if you want to shoot me an email or DM on Twitter, I am always happy to answer questions. So we are going to do a brief overview of availability groups, what they are, and then the prerequisites for creating an availability group in Azure. And then I'll run through the process of creating a multi-subnet AG. My plan is the process takes about 25 minutes to 30 minutes to build out the AG, and I'm going to talk about availability groups and how they work, and if the AG that I'm building as part of this presentation comes back, I'll log into that one. If that doesn't happen, I've got one built out that I built out earlier today, and just take a look and show you what everything looks like. So just before I get started, what do people here do? I know what you do. I kind of know what you do, but they're DBAs, app developers. Is there anybody who does Windows for a living or networking for a living?
Well, I mean, networking for a living as a platform, yes, but it's mostly coding, and then
So let's talk a little bit about what an availability group is. Microsoft's definition is that an always-on availability group feature is a high availability and disaster recovery solution that provides an enterprise-level alternative to database mirroring. So that's basically how it was introduced. If you think about database mirroring, you've got a database, you are mirroring it to some number of locations, some number of partners. Availability groups do a similar thing, but what's different about availability groups is you can have multiple databases in an availability group. So if you've got an application that has got 3 or 4 databases that it uses, you can put those in an availability group, and then you can get high availability and disaster recovery for that group of databases. Something else to point out is that because this is at a user database level, system databases like master and model do not participate in availability groups. at least as far as what I'm talking about here. With SQL Server 2022, they've introduced a new feature where you can effectively create a copy of those databases that will live in your availability group. Because one of the challenges with what I'm going to talk about is things like logins and jobs that live in the master and the MSDB database. Those do not fail over. So you have to actively sync those between the replicas. So talk about this, the group of databases. You can replicate that database from one primary server. You always have one primary or one replica server that's acting as your primary replica. And then you can have up to 8 secondary replicas. It provides high availability and disaster recovery. And it runs on top of a Windows Server failover cluster. If you're familiar with failover cluster instances, it is different than an FCI because with an FCI, it's failing over at the instance level. So everything in the instance, master, model, MSDB, that is all failing over along with all of the user databases. Here you are defining which databases are in your availability group, and that is what is failing over. The communication between your replicas can be either synchronous or asynchronous, and I'll get into that in more detail in how availability groups work section. And then your failover between the replicas can be automatic or manual. So if you have the communication between your replicas is set to be synchronous. The availability group can fail over automatically. So if there's an issue with the instance of SQL Server or an issue with one of the databases and SQL Server can't connect or access the database, it will fail over to a replica that is specified for automatic failover. One other very important piece of an availability group is a resource called a listener. So a listener is a cluster resource, and it is basically a pointer to the primary replica. So you build out a failover cluster that sits underneath the availability group, and the listener gets built as a resource in that cluster. And there's an IP or group of IPs associated with that listener. And when the availability group fails over, that listener points to the new primary. You can have replicas in multiple subnets, and that's what the demo I'm going to show will build out. And that listener requires an IP address for each replica subnet. And you can kind of think of a listener, if you're familiar with Active Directory, it's sort of a C name. It has the same kind of characteristics, so pointer to an IP or group of IPs. And it is how applications connect to availability groups, because you can connect directly to the primary replica, but if that availability group fails over, that connection to the primary replica will no longer work. Connecting the application connected to the listener, when the failover happens, you'll see a blip. I generally see, like, if you go ping T on failover, it will maybe drop a ping. So your application should have retry logic, but it will connect to the new primary. So requirements for creating an availability group. And these are the requirements for creating an availability group manually in Azure. So what I'm demoing is a process of doing this automatically, but these are the requirements. So you need a resource group. You need a virtual network with 3 subnets, 2 for the AG replicas and 1 for the domain controller. A domain controller with DNS enabled, and then a VNet configured to use the DNS IP. So when you build out the virtual network, there's a tab that you can specify a DNS IP. It defaults to it automatically defaults to a system generated IP for DNS. You need to change that in order to have the domain controller talk to your replica servers. Then You need 2 domain joined VMs for AG replicas. You need a Windows Server failover cluster containing the AG replicas and your domain controller. You need an IP address or IP addresses for your listener configuration. You need to configure your SQL logins and service accounts. You need to set up firewall rules to allow communication between replicas. And then you need a storage account for a file share witness. That is a lot of stuff. And it's not, in the wheelhouse of your average DBA. The domain controller can be a challenge to set up. But we're going to talk about this automated process. So this is the first slide of requirements. With the Azure Portal, you need a resource group, a virtual network, but you only need a single subnet. The additional subnets will be created as part of the setup process. You still need that domain controller. And I've actually got a PowerShell script that will build the domain controller out. It will provision a VM. It will install the tools you need for Active Directory, and then it will promote that VM to a domain controller, and then it'll set the VNet that you specify to use the DNS IP. There are 2 additional steps you have to perform, and I'm working on getting those into the PowerShell script. Basically, you need to create the cluster resource before the deployment, and it's a simple process in Active Directory, but I'm just trying to get that to be a single script that you run, and it's done, you can go straight to the portal. And then here, these are the second slide of requirements. None of that is needed in the portal, or at least it doesn't have to be set up by you. The process will generate all of these resources for you and configure everything for you. So I will jump into the demo. So I have an availability group here. As I said, I've created my domain controller and I actually have one pre-built just in case this runs long. But what I'm going to do is click create. And then in the marketplace, I want to look for Azure SQL. So I get an option here for Azure SQL. I click that. My plan is Azure SQL. With that, and I get 3 options: SQL databases, SQL managed instances, and then SQL virtual machines. And I select an image. In this case, I'm going to pick SQL Server 2022 Developer Edition. And then there's a high availability checkbox here. I check that, and that is what gets me the AG build. So I click create. And I just want to verify that I'm in the right subscription and the right resource group. I can specify up to 9 virtual machines here. I am just going to use 2 because I'm cheap. And then it defaults to myVM-1, myVM-2. I can edit those names, get a little more creative. And it will populate those names for me. I give it a region. I've got my image, and then I specify the size of the VMs that I want. It gives me a default. And once again, because I'm cheap, I'm going to run 2 cores and 8 gig of memory. So I give it the size, and then I need to give the virtual machines an administrator account. And this is going to be a local Windows account. So it'll be a Windows account on the 2 SQL Server nodes, or the 2 VMs I'm building. So I give it password. All right. And then if you have any sort of hybrid licensing, a hybrid benefit for your licensing, you can check the box here. It will save you money for both Windows and SQL Server. I'm not going to do that because I'm using the Dev Edition, and I'm going to delete these very quickly. So the next thing I want to do is click on the networking button here. That will take me to networking, and I select a virtual network. I've already built this one out, so I select that. And then I want to allow selected ports. So allowing port 3389 will allow me to RDP to these servers. If you don't select that, then you're not going to be able to make a remote connection. Then I said that you need a subnet per VM for this configuration. So I click that link. And then I just add a pair of subnets. Call this SN3. Click save. You can change your subnet address range if you want to use fewer addresses, but I'm just going to use the default. Save that. So that is provisioned my two subnets, and you just confirm that they're both there. So SN3, SN4, and then I just click the X here to jump back. And then I can assign those subnets one to each of my replicas. And you can see that it pre-populates or automatically populates the listener IP address. So I've got that set up. There's a checkbox here to delete newly created public IP and NIC when VM is deleted. I usually just delete the resource group when I'm done, but if you check that box, you can delete the VM and it'll delete any associated resources with it. So the next step is the Windows Server failover cluster and the credentials. So I give it a cluster name. Actually, here's one other thing here. Give me 1 second. Forgot to pre-create the cluster. So you can see what that process looks like. I'm try a PowerShell for this. Afraid that was going to bounce. All right, and so this is my domain controller. I'm in Active Directory. I just need to create a new computer. Click OK. Now if I look at computers, you can see that I've got that machine here. I need to disable it. And then I need to grant it. I need to grant it create computer object, because basically what will happen is when the AG is built, that cluster resource is what is responsible for creating the listener. So it needs to be able to create that listener object in Active Directory. So I go to Properties, Security, Advanced. Look for computers. Okay. And it's just telling me that the object's disabled. Basically, the domain admin account now has rights to this, the way I'm doing this. So it will all work. And okay, drop back to the portal. All right, so I give it that cluster name that I just pre-created. And then I need to create a witness storage account. So with a 2-node AG, I need to have a third vote for the cluster. And so this storage account that I'm going to create here will act as that witness. And it told me, I'll show you when we jump back to the previous screen, but you need to select storage V2 general purpose v2, and local redundant is fine. Okay. And you can see here, it tells me that it won't tell you on the create screen. So if you create it with v1, when you come back here, it'll let you go through again. So just keep that in mind. And then I need to provide it with domain credentials to build the cluster. And so I've already created an account that I can use, and that's part of the PowerShell script. So, local. So that is my FQDN, my fully qualified domain name for my cluster, or sorry, for my domain. All right, so got that. So I've got everything I need for the failover cluster. The next choice I have is disks. So these VMs are going to be built out, and by default, they get built out with 3 drives. They get built out with a SQL data drive, a SQL log drive, and then there is a local SSD drive on each machine that will host the tempdb files. You can change this configuration. Here you can actually add more drives. You can make the drives that exist bigger. I'm going to leave everything set to the default. And then here, this is a checkbox that is really handy. So there's a checkbox here that defaults to delete with VM. So if I delete one of these virtual machines individually, it will delete all of the storage that's attached to it with them. When VMs or when Azure first started, that was not true. And basically, with a VM, if I'm running a VM running SQL Server, if I turn that machine off, I'm not paying for the licensing for Windows or SQL Server, but I am paying for any of the storage that's attached. And so people would get angry because they would delete a VM, but the storage would stay out there, and they would get a big bill. So that checkbox will get you around that problem. Next screen is the SQL Server settings. So this is where I define my AG name. I call it AG2, and then my listener name. G-list2. And then I can set my automatic failover and sync commit. And then I can also specify something I didn't mention with availability groups is that the secondaries can be set to be readable. So you can read from secondaries. So if you have an application that's running OLTP, but you also want to be reporting off of it, you can point the report at your secondary. And then you can pull that data out, and it's not going to interfere with your transactional workload. SQL connectivity, just going to leave the default as private through the network, and then port set 1433. I'm also going to leave SQL authentication off, so be Windows only, but you can enable that, and then it will prompt you for an SA or an admin login and password. I'm also going to leave the Azure Key Vault integration off. That's a feature in Azure that will allow you to store credentials in Azure Key Vault, and it's a more secure way to do things. For this demo, I'm not going to mess with anything. And finally, you can change the default configuration of the instance. So right now it's set to max.0. It's got max memory, the 2 terabyte. Is it 2 terabyte or 2 petabyte? It's real big, whatever it is. It's all the memory. And then you can change your correlation. And then you can also enable our services. It's grayed out. I messed with that. So that gets me everything I need for the availability group build. Next screen is tags, which I'm not going to do anything with. This is a way to identify who owns resources. So if you have multiple application areas that have things in Azure, you can set tag values here. So you can run audits. You can use it to figure out who owes what when the Azure bill comes. And then finally, I'm going to go to review and create.
Yeah.
This will show me everything.
Late.
Hey, Steve, could you mute your mic, please? Okay, just did.
So this shows me everything I've selected, so you can just review this and make sure that everything looks good. Just verify you didn't fat finger anything. So it shows me everything, and then I click create.
And cross your fingers.
Yes. And it's worked. Once I did it right, because the Microsoft documentation for this doesn't include a step. It's in another piece of documentation, but it was fun.
We're pretty good at that.
So now this is deploying
Yeah.
everything on Azure.
Yep, yeah, so you're gonna see, let me refresh this, it should pop both of them up. So right now it's creating the two VMs, and then the next thing, once those complete, you'll see it pop up and say it's joined to the domain. Then it's gonna create the cluster, and then it'll create the availability listener, or the availability group listener, and then it will be done. So while this runs, I'm gonna jump back to the deck. Does anybody have any questions before I go on? That's a lot that I just went through.
Is it possible to set this up with in a on-prem Azure type scenario?
No, as far as I know, you can't use this tool to build a hybrid AG like that with an on-prem node. I mean, that is possible to do, it just won't work with this. This is all in Azure.
Gotcha.
Excuse me. So, here's my clicker. So just to go over how an availability group works. So everything that runs within an availability group runs off of the transaction log. So in SQL Server, the default behavior is auto commit, which means that if I go into Management Studio and I say delete from table and I don't give it a where predicate, it's going to delete all the rows. Well, it's going to wrap that delete statement in a begin transaction and a commit transaction. And because SQL Server adheres to ACID properties for databases, that transaction, so let's say that delete without the where predicate is deleting 1 million rows out of a table, and I get halfway through that 1 million deletes and my server crashes. When the server comes back up, that half transaction is not valid, so it will roll that information back. It's only when the transaction completes and commits and flushes those transaction records to the log file on disk that the transaction is done. And this is just talking about a single instance of SQL Server. The way the availability group works is as those transactions are writing to the log file on disk on your primary, the log blocks that contain those transaction log records are being transferred to your replicas, to your secondary replicas. And depending on whether you're set synchronous or asynchronous will determine how that secondary replica behaves and how the primary behaves in relationship to that. So I talked about this. So I've got my transaction. My records are writing to the log on the primary. Log blocks are transferred to the secondary replicas, and this is for synchronous mode. So they're transferred to the secondary. They are written to the file on disk on the secondary, and then there's a notification that that log write has completed. That's sent back to the primary. And at that point is when that transaction commits on the primary. And this is why with synchronous mode, Microsoft guarantees that you will not lose data for any committed transactions on failover. And I'll show you what the dashboard looks like. When you look at the dashboard for an availability group, if you are in synchronous, there will be a column on the dashboard that says no data loss. And that means that when you fail over, you're guaranteed that any transactions that were committed, you will not lose those transactions. Just like a single instance of SQL Server, if I'm in that scenario with 1 million deletes, I get halfway through. When SQL Server comes back up from a crash of a single node, or when it comes back after a failover, because SQL Server can't have a transaction, it's going to roll those records back, roll those transaction log records back. So that's synchronous. And just to show you what this looks like, we've got the big circle or big rectangle is my failover cluster. Within that, I've got a pair of VMs, and then I've got SQL Server installed, and I've got 2 replicas, 1 and 2, and there's my availability group. So replica 1 is running as my primary. I have a transaction, and the log blocks associated with that transaction are transferred over. They get to replica 2, they commit over there, that notification goes back, and then I get a commit on the primary. And this is happening constantly. It's pushing those log blocks over. Synchronous mode is generally recommended for machines that are close to one another. You need to have a fairly quick network connection between those machines. So in the same data center, in the same rack, the closer the better. If you start to move them farther apart, then you have a potential for latency here. So both this transfer and then that notification coming back, if you have distance between these nodes, you can run into issues because things will queue up. I'll also show you over the dashboard, you can see metrics for your send queue. So those log blocks can queue up on the primary server waiting to go to the secondary. And then the same thing can happen for the notifications going back, and then also the apply on the secondary. If you have slow disk or issues with your disk, you can slow down the rate at which things are applied on the secondary, and all of that can cause problems for your availability group. So that's synchronous. Async, basically the primary just runs like a normal instance of SQL Server in this case. Transactions are log on the primary replica and it commits. The log blocks are pushed over to the secondaries, but it doesn't wait. Stuff can queue up on your secondaries all day long, and it doesn't care because you're async. And in this case, the standard when availability groups released, the diagram that you would see in Microsoft documentation was data center 1, I've got my primary replica and a secondary replica, and those are synchronous. And that gives me high availability. And then I've got data center 2 that could be hundreds, if not thousands of miles away. There's a replica in that data center that is asynchronous. And that secondary replica is for disaster recovery. So somebody cuts a power cable or cuts the network cable to data center 1, my disaster recovery plan kicks in, and there is a process to bring those databases up on that replica in the second data center. And there is an understanding in that disaster recovery plan that you are going to lose data. There is a guarantee that you're going to lose data because it's very possible that transactions have not committed on that secondary node. So it's defining what your recovery time objective and your recovery point objective are when you set this architecture up. So it's just something to keep in mind. And once again, just to show you what this looks like with the diagram, async, I've got the transaction commits, and then the log blocks transfer over, and then at some point they commit, and the primary replica just continues to run. It's happy to do what it does. So that is the async commit. That takes me to the slide deck. Let's see where our deploy is. All right, so I'm deploying my failover cluster, and that's most probably going to run for another 15 minutes or so. So I will jump into one of my nodes. So as I said, I ran through this process earlier today, And I have not done anything with this after the deploy. So this is VM1. So this is currently set to the primary, and you can see that here. I've got my availability groups, my availability group name, and then my two replicas. And VM1 is primary, VM2 is secondary. I haven't added any databases to this availability group. We'll do that in a moment. But there is my availability group listener. Let me show you what that looks like. If I look at properties, you can see that I have two IP addresses defined. I believe the 06 is for the subnet that VM1 is in, 26 is for the subnet that VM2 is in. And this listener resource, I can actually connect to this. Don't tell luckily. This one. So I am connected to the listener. And if you take a look, it's basically the same view. So I'm now connected to VM1 through that listener name. And if I was to fail over, it would switch to VM2. And I will fail over before we get out of here. So this is all, the automated process builds out the infrastructure for the availability group. At this point, there are no databases in the availability group, and the automated process isn't going to do that for you because it's building these machines out fresh. There are no databases to install. But I have restored a copy of Wide World Importers on VM1. I just need to make one other change that I forgot to make before. So what I'm doing is I'm going to set Wide World Importers into full recovery mode, or full recovery model. And then I'm going to run a full backup because when you set recovery to full from simple or bulk log, it doesn't actually set to full until you run your first full backup. So importers, and a neat trick I'll show you. Disk equals. So N, and then the letters NUL in quotes. This will run the backup of the database, but it basically just dumps the backup into the ether. It doesn't actually run to a disk somewhere. It's really useful if you just don't care about the backup, which I know in this case. It also can be really useful if you want to get timing on what your backups are going to do, because the backup statement actually runs through all the process that it would. It just doesn't save the backup file. So that actually turn on both of those. All right, so that is done. So now, if I right-click on availability databases and say add database, click in the wizard, and it shows me that I have one database here, and it meets the prerequisites. If I had done this before I set recovery full and ran the backup, the status would say full recovery required. If I set full recovery without backup, it would tell me that full backup was required. Because I've done those two things, I'm good to go. Click next. I need to connect to my secondary, so I will do that. And then next, and then it gives me a screen asking me how I want to synchronize my data. So when availability groups were released in SQL Server 2012, the way that you set up a secondary is you took a full backup and a log backup for each database you wanted to put in the availability group. and you restored that on your secondary or secondaries in no recovery. And then you built your availability group and it would sync things up. I can't remember if it was a service pack or a CU for 2012 or 2014. They gave you the option of where it would run the full database backup and log backup for you. You just needed to provide it with a shared path that both of those machines could see. And then 2017, automatic seeding, do you remember, Jared? It's 2016 or 2017. They released what's called automatic seeding.
I don't remember, but I think it was 2016.
And what automatic seeding does, and that's what I'm going to do here, is it basically does the seeding and does the population or creation of the databases on your replicas automatically behind the scenes. For demo purposes, this is great. If you are building out an enterprise or a production level availability group, as a DBA, I'm a control freak. I like to know what's going on, so I may do my own backups and restores. But it is a labor saving option. So I'm going to select that, click next. It's going to validate that you got enough space on your secondary server to build the database out. Check that the database doesn't already exist and the database files don't already exist. And then the last one is checking the compatibility of the database file locations. And what that means is that in this case, I think it's an F and a G drive for my data and log. The secondary replicas should have the same paths to my data and log files. They don't have to, but for sanity's sake, it is a good idea to have them. Because if you don't have them set the same way, it can be a nightmare to troubleshoot things. So that's what that last check's doing. Click next, just tells me what I'm going to do. I'm going to build out an availability group or add a database to my availability group using automatic seeding. I click finish, and it is done. It is adding them. So now I mentioned the dashboard. If I right click on my availability group, say show dashboard, it is already synced. So this. So you can see, if you read this from the top, my availability group, the high level, has got a green check. My availability group state is healthy. It tells me which instance is running primary and what my failover mode is. Tells me my cluster is in a healthy state, and then I'm running in WSFC. And then it gives me information about my replicas.
I don't know. Is that your fan?
It's the amplifiers and everything over in the corner.
Okay.
Seems to happen around this time every week.
Oh, yeah, that's right, yeah. It happened to us last time too. We were wondering who that was.
And so below that, I've got my availability replicas, so my two server names, primary and secondary, both in synchronous commit, both in automatic. I'm not sure why the CD mode is at the menu on we have one, but my synchronization state is synchronized. So that means that everything is in sync between the two. Everything that has committed on my primary has committed on my secondary. And if I fail over, I'm not going to lose any data. If this was asynchronous, that synchronization state would read synchronizing. And once again, that means that the connection between the two replicas is healthy, but because it's async, it is not necessarily synchronized. And then at the bottom of the dashboard, you've got the databases that are running on each replica. I think in the test that I ran previously, when I opened this dashboard up initially, the database on VM1, which is my primary, was green. The database on the secondary had a yellow caution sign, a yellow triangle with the exclamation point, because the seeding process was still running. And then once the seeding process completes, it will go green. You see the no data loss there?
Frank, we do have a question on the
Sure.
chat here.
Okay.
So it's, can you show the log queue and the read queue?
You know, they say a great question is the one that's on the next slide.
Oh, yeah.
It's the one, the button I was about to click. So by default, this is what it shows you. It just shows you replica, synchronization state, and failover readiness. There is an add remove columns button here, and this gives you additional options. The ones I'm going to select are estimated recovery time, estimated data loss. I got to talk to Aaron Stellato about making this multi-select. This is a pain in the butt. Synchronization performance, log send queue, log send rate, redo queue, and redo rate. The other ones that are in here give you very detailed information about log sequence numbers. That's what LSN stands for. So if you're doing some hardcore troubleshooting, looking at the transaction log, you can figure out, what exactly is going on in terms of commit time, sent time, receive time, harden time, and redone time. So it's all, like I said, really granular information beyond the scope of what I'm talking about here. But if we take a look now, this may not all fit. Oh, my best. So this is not terribly exciting because there's nothing happening with this database right now. But this basically tracks that slide that I had, or a series of slides that showed you that round trip process. So the log send queue size is the size of data that is on the primary waiting to go to the secondary. Log send rate is how fast that data is being transferred over. The redo queue size, that is the size of data on your secondary waiting to be applied. And then redo rate is how fast that data is being applied. As I said, right now, not terribly exciting because there's no activity. But if you have a situation, and I've had this situation happen before, where you lose connectivity to the secondary for some reason, and you can't move data over to the secondary, that log send queue will get big. And when you restore that connectivity, it will start pushing it over, and you will see the log send rate, log queue size divided by your log send rate is your estimated recovery time. The redo rate, redo queue size divided by redo rate, that will tell you how much data you may lose, because until the redo queue size is 0, that data could be lost, because that means that transactions that are committed on the primary haven't hardened to the log on the secondary. So that gives you kind of an overview of the health at a more detailed level. This stuff is all available for DMVs, so if you're interested, I have queries that you can run that will pull the same information back. But it's really useful if you run into issues with connectivity between replicas or issues with the replicas themselves. So it's a good thing. I say when you've got a C-level person standing behind you asking you when it's going to be done, I don't know is usually a pretty bad answer, and this will give you something other than I don't know. They are estimated numbers, but it's usually gives you a pretty good ballpark of when things should be healthy again. So that is dashboard. Just so see what a failover looks like. So what I'm going to do is connect to my secondary replica, and pick it up. I'm always on. See that. So this is the secondary. got my replicas, got my database, got my listener. So if I right click on my availability group name and select failover, it tells me that I am going to, my current primary is VM1, and I am going to choose my new primary replica. I only have one to choose from, so it defaults to VM2. Tells me again that I'm synchronous automatic with no data loss. So I click next, gives me a summary, tells me what I chose, and then click finish, and that will fail over. If I did the same thing from the primary node, I would actually have to connect to the secondary. But because I'm connected to the secondary through Object Explorer, I don't need to do that. So I'll click finish, and it will run through the steps, perform manual failover, and if I refresh the dashboard for the primary, you'll see that there's my red or yellow triangle. So I'm now secondary, so the secondary only knows about itself, and that's why the other replica disappeared. And it is, it should not help. Let me see if I refresh this, it should go green. Yeah, okay, cool. So it basically, the database went healthy and it refreshed before it knew that the replica was healthy. But if I look at the dashboard for VM2, it'll look familiar. So I've got both replicas, databases for both replicas, everything is green. And like I said, that failover, if I was to run a ping T against the listener IP while that failover happened, I might lose a ping. So it's a really quick process as long as your replicas are close to one another. If I had, this running, VM1 running in East US, VM2 running in West US, and I had them set to synchronized, it would not be so happy. So just things to keep in mind. I'm trying to think if there's anything else that I can talk about. Any other questions, Ross?
No.
Okay.
Thank you, Frank. It was very good. Thank you.
Let me just take a look and see. So I'm still deploying my listener cluster. Join the domain, created the cluster. It's creating a listener now. And it's what, I probably started this about 25 minutes ago. This is much easier.
Yeah.
If you've ever had to, the domain controller, you still have to create, like I said, I've got the PowerShell script that I will have a link to in my slide deck. But, joining the machines to the domain, building the failover cluster, I've gotten pretty good at it, but it's one of those things I was putting the slide deck together with the screenshots of what it was doing. And it's one of those things where if you do it enough, it's really easy. But then when you try to tell somebody else how to do it, you're just like, God, there are a lot of steps here. It's hard. All right, so it's done. So, go to my resource group. You can see I've got my two VMs, VM4, VM3, and then this for Snix and Yucks, I'll just connect to 3 and show you that I don't have anything up my sleeve. So it's the fresh install, because I deployed a SQL Server VM, SQL Server is already installed, it's got the AG built out. It's taking care of a lot of busy work for me. And like I said, I'm interested in this from the ability to stand up an availability quickly to do demos. But I think there's value in this for deploying things to production. Just takes a lot of work off the hands of whoever's doing it. Where you could potentially run into problems if you're in an organization that has a Windows team, a networking team, and a storage team. They might not be so keen on it, but it makes it easier for a DBA to perform this task and kind of avoid a lot of non-DBA work. So open Azure Studio. Actually, one other thing I'll look at while I'm here. Just to show you what the cluster looks like. So I believe I call this cluster failover cluster 2. Connect to it. Yeah, so there's my, I'll zoom in install. That's my cluster. If I look at nodes, you can see I've got VM3, VM4, and then my role, there's my availability group. If I click on the availability group, you can see my listener down here. So that's my client access name and then the IP addresses that are associated with the listener. And so that, because this is part of the cluster, that's what allows the listener to connect to the primary regardless of where it's running. Management Studio takes too long to open.
Especially when you're screen sharing.
I never-
Yeah. Oh, yeah, it's like they butt heads, Teams and SSMS, yeah.
Wow.
But just the screen share.
Yeah, and then here you can see that the IP address for the subnet the primary is in is online. If I was to fail over, that would go offline and the bottom one would come online. So I'm just going to go to VM3. I apologize for the size, but always on.
We forgive you.
There you go. So no databases because I haven't created anything, but all of those resources are there. And, you know, it was going through about 6 screens in the portal where it's much more complicated than that if you're going to do this manually. You know, just the domain controller build itself is a really complicated process. So it's just a cool feature. I think it has a lot of use. It is in preview, so things can change. But I think that the general process will remain the same. So, any other questions?
No, we're good.
Okay. I'll just jump back to my slides real fast. Just once again, what we covered, just the overview of AGs, how they work. That should be at the end. Prerequisites for creating an AG in Azure, both manually and through this process. And then that process for creating the AG through the portal. Got some resources. The first 2 are sort of introductory. And then the last one is actually the Microsoft documentation for creating an availability group in the portal. I mentioned, I think before the recording started, but If you look at those instructions, there is a step missing, and that is the step where you need to add the DNS IP for your domain controller to your virtual network. If you don't do that, the domain join will fail. And that was really frustrating until I actually talked to somebody who knows something about networking in Azure. They were able to point me in the right direction. So that just a caveat, and hopefully they'll update it because I told them. But we'll see. So that's the resources, and then my contact information. If you want to shoot me a question, I joke that I like to talk about this stuff and my wife doesn't, so any and all questions are welcome. Apparently you've heard that joke. So
Or live it,
that is what I got.
it's not a joke.
For real. And I'm big on conversation about technology.
So,
Thanks so much, Frank.
Yeah, thank you, Frank.
Thank you, Frank.
this is a fun one.
All right, I'm gonna stop the recording.